Hi everyone. In this video, we would be learning about adapter design pattern, which is one of the structural design pattern. So let's start learning this design pattern with the help of example. By the way, this is the definition for adapter design pattern, and it says that it allows two incompatible interface to work together by converting one interface into another that the client expects. So we'll understand this definition properly, but the keyword over here is interface. So by this interface, we are not referring the Java interface. We are not referring this Java interface. Instead, we are referring the function. Many times we use interface as the term for the functions or the APIs, right? So this interface is nothing but this function. So coming to the definition again, the definition says that we are making two incompatible functions work together by converting one function into another. And why we are doing so, let's understand that first. So let's assume that you have an application which has couple of payment gateways integrated. First is the Stripe payment gateway. Second is the Razorpay payment gateway. Okay. Now, Stripe payment gateway has provided you one API, and that API is make payment, and you have to pass the card number and the amount in USD. Similarly, Razorpay has provided you API which has the name called as create payment, and you will pass the phone number and the amount in paise. Okay, point to note over here is the amount is in paise, and also the name is different, right? So in the client, what you'll do is you'll first of all get the gateway which user has selected. So user can select the Stripe, or user can select the Razorpay, or user can select the PayPal. Okay, then accordingly you will call the API which is provided by the particular payment gateway. So if user selected Stripe, you will call the make payment, and then you will pass a card number and the amount in USD. And let's say user selected Razorpay, then you need to first convert the USD to INR and then to paise, and that paise will be used in this API create payment. Okay, similarly we would have the logic for the PayPal as well. Now the key point over here is, in future, let's say if you want to add one more payment gateway, then you have to have this else if statement. So you would add one more else if statement over here, right? And secondly, these APIs are third party API, and the changes to that API is not in our hands. All of a sudden, let's say Razorpay decides that instead of using amount in paise, they start using amount in USD. So we have to come to this class, we have to remove this conversion logic, and we have to use this amount of USD instead of amount in paise. So both of this point are violating one thing, which is open close principle of solid principle. So that's the reason why we have to come up with another approach which will not violate open close principle, and it will help us to deal with third party APIs like this. The best answer for this is adapter design pattern. So in the adapter design pattern, what we are doing is, as you can see, this is the API, or you can say interface make payment. So according to adapter design pattern, we would convert this interface into another interface which is pay amount, and make both of them compatible with each other. So currently make payment and pay both are incompatible because the naming is different. Further, the total number of argument is different. Here we have two arguments, here we have only one argument. So we have to somehow convert the make payment function or make payment interface into pay interface. And this can be done with the help of adapter design pattern. Similarly, here also we will convert this create payment to pay amount with the help of Razorpay adapter. Okay, all the conversion logic for USD to INR will be residing in this adapter itself. Okay, and now after this we have this unified solution. Now the client will not use if else statement. Instead, it will just call pay amount. Whether user selects type or whether user selects Razorpay, we will just be using pay amount. So this was the first example. In this example, we were dealing with the third party API because it was clearly violating the open close principle. Now, what we'll do is before checking the code, we will also check out one more example for adapter design pattern. So this example is related to the data format. So one service is fetching the data and the data returned is having the JSON format. So let's assume that your entire code base is dealing with the JSON format data. But now for some reason you have to interact with this legacy service. By legacy we mean that it's old. So for some reason you have to deal with legacy service. But the problem over here is this legacy service will return the data which has XML format. Okay. It means that in the client code, you need to check whether the data has XML format or the JSON format, and accordingly you have to process it, right? And again, it will be violating open close principle because you would have if else statement. Plus, in the future, if you introduce or if you are dealing with some other legacy code which has some other type of data format, then again you have to use or modify that client code, right? So what we have done over here is we have introduced one adapter in between this legacy service and the user service. And in this adapter, we are fetching the XML data, and then we will convert that XML data into JSON data, and we will then return that JSON data to the calling service. It can be the main.java or any other client code. Okay. So over here, we were dealing with the legacy code, and over here, we were dealing with the third party API. So if you ask me when to use the adapter design pattern, then the answer would be these 3 points. First is whenever you want some unified interface. Over here, we wanted this unified interface called as pay amount. So we converted this API or this interface into this interface. Also, we converted this interface into this interface. In this, we converted this fetch data where the output is XML to fetch data where the output is JSON. Right. So we wanted one unified interface in both of those examples. So whenever you want unified interface, then I think you can use adapter design pattern, provided you are dealing with either the legacy code or you are dealing with third party API. So I hope now you understood the definition where we were having two different interfaces like this, and we were converting one of them into another, which will be used by the client. And I hope you understood the examples as well, both of the examples. Now let's see the code for both of the examples. So this is the pay function which will use by the client, and this function will take one argument which is amount in USD. Okay, so all the adapters will have to implement this function. So over here we can see that Stripe adapter has this pay function, and this pay function, in this pay function we would be calling the API which is provided by Stripe, and the name of that API is make payment. and over here we would be passing all the required details. So by the way, this required details uh, will be assigned when we are creating the object of Stripe adapter. Okay, and we would also pass this amount in USD through this function, right? So this is how we call the third party API, and we are making this third party API compatible with this API with the help of adapter, because we are wrapping this third party API into this function, right? So in the Razorpay adapter also we'll do similar stuff, but over here, since it needs amount in paise, we would first convert the amount in USD to amount in paise, and then we would pass the amount in paise over here. Okay. So over here as well, we are making two incompatible interface. This is the first one. This is the second one. We are making both of them compatible with each other by wrapping them into this function and processing all the required logic. For example, this is the one requirement, that is amount in paise is required instead of amount in USD. So you would process that stuff in this function itself. Okay. So now I hope you understood both the adapters. Coming to the main.java, over here what will happen is user will select a particular payment gateway. For example, let's say user selected Razorpay. So accordingly we'll create one adapter. If user selected Razorpay, then this adapter would be created, else Stripe adapter would be created. So by the way, for creating objects based on user input, we can use factory design pattern. So over here we'll use factory design pattern. I have not used over here factory design pattern. You can make a factory for this. That's up to you. And if you don't know about factory design pattern, you can watch the video. I have created one for factory design pattern. You can go and watch. So once we create the adapter based on the user input, what we'll do is we'll just call the pay function, because all the adapters are implementing this pay function where they are taking the amount in USD. So we'll just call the pay function and we'll pass the amount in USD, where here we have passed $50. And by the way, we are using this strategy design pattern over here. How? So see, if you don't know about strategy design pattern, you can watch my video. I have one on that as well. So in the strategy design pattern, we dynamically change the algorithm of a particular function. So the pay function, so if the user has selected the Razorpay, then the pay function of Razorpay adapter will be executed. If user has selected Stripe, then the pay function of Stripe will be executed. So basically we are changing the pay function dynamically. Hence we have indirectly used or directly used strategy design pattern. Okay. So total we have used 3 design pattern in this example. The first is, by the way, sorry, we have not used, but we can use the factory design pattern. So first factory design pattern, second strategy design pattern, and the third is adapter design pattern in order to make this particular API compatible with this API by wrapping the make payment into pay function. Now let's see the second example. So in the second example, we had this interface where this was a function which will be implemented by both of the service, JSON service and XML adapter. So in the modern JSON service, the fetch function will return the JSON data or the JSON response. Okay, wherein in the legacy XML service, the fetch function returned XML data like this. So what we did was we added one adapter between the calling service and the legacy XML service. So over here, we injected the legacy XML service using the constructor, and we called that legacy XML service fetch function in the fetch data function of this adapter. And once we got the XML data, we converted that XML data and we return the JSON data. So in the main class, as you can see over here, first we have created the legacy XML service, and we have injected the legacy XML service into this adapter so that the adapter will convert the XML data into JSON data, and we will then use the JSON data. So if I run the code, we would have the same output even if we were dealing with legacy XML service in the first example. And this was made possible because we introduced adapter design pattern. So I hope you understood both the examples. If you have any doubt, you can comment down. And if you understood everything, please like the video and subscribe to the channel. Thanks a lot for watching.